Hello, my name is Jack Evans, I'm 22 years old and I'm studying BA Product Design. This year it has been my driving principle that I approach every new design challenge with an optimistic and enthusiastic mindset. It has made me realise that as a designer I am part of a much larger group of people that share a fundamental passion for creativity and problem solving. This year I've been reinvigorated by every new project that I've taken part in, and I've gained a sense of fulfillment from designing for those often forgotten about in today's consumer-driven society. The three projects I'll be discussing in this video are Justira, my field project, and DS Smith. The significance of all of these projects was that they provided a nice variation. Each project required a different skill, a different way of thinking, and challenged me creatively to deliver innovative projects in a limited time frame. To start my final year, we took part in the W2W Greyfox Design Competition. The brief was to create a collaborative workstation using principles from the circular economy. The circular economy, out of chance, was the main focus of my dissertation at the time, so I felt pretty confident coming into this project. In an attempt to make our design stand out from the competition, we decided we should try and tackle another key problem within the workspace environment, on top of the competition deliverables already required. From our observations at local offices, libraries and workspaces, we noticed that a lot of students are working in as what we labelled as bad posture positions. These positions could potentially cause back pain and put stress on muscle groups surrounding the spine and neck, which could later result in long-term injury. In an attempt to solve this problem, we began the ideation stage. We began ideating, trying to discover how we could go about solving some of these problems while sticking to the competition requirements. During the ideation stage, we completed processes such as Crazy Eights and brainstorming. These methods were essential, as with such freedom in a project, it was important we thought of all possibilities before committing to one design. We looked into key areas of the circular economy and decided from an early stage that we should use design for disassembly to ensure that our product could be easily dismantled and recycled. A lot of other groups were tending to focus on designing a collaborative hub, so I wanted to take our design down a different route, something that was portable, adjustable, and 100% recyclable, as well as improving posture. In order to do this, we started looking at adjustable furniture already on the market. We set up a focus group to see how students interacted with an allocated desk space. This was helpful because it made us realise that in order to achieve good posture, we needed to allow the height, tilt, and position of the desk to be fully adjustable. All three of these things also benefit collaboration. Once we felt we had a good understanding of what we wanted to achieve, we individually began sketching some different ideas and then came back together to share them. Once we decided upon a final concept, we started looking into areas such as stability, how the desk is adjusted, and how the workspace can be transported. We took inspiration from IKEA's flat-pack furniture range and also tilting adjustable whiteboards located in the studio. We wanted to keep the design very simple so that it could be recycled. This would also reduce weight and allow for full customization of the workspace. Here is our final concept. The product allows for the user to adjust and customize their workspace. The desk can be tilted and positioned to fit the user, as well as being 100% mobile to set up collaborative work areas. This project can be quickly constructed from a flat pack form. To keep the design within the requirements of the circular economy, not only does it involve no permanent joining methods to make recycling easier, but the product is made out of one material, 100% recycled Swedish oak. We then developed finite details such as looking into social indicators to encourage collaboration within the workspace. These work by the user being able to adjust a pin in the desk to indicate to other workers when they want to share ideas or when they would prefer to work alone. This meant that the users could work without being interrupted and without them having to separate themselves from the work environment. The pins also allow the user to attach stationery holders, iPad or presentation boards to the desk. This project was a nice start to my final year, and it even enabled me to reference it in my dissertation work, which I am very proud of. This work gave me the confidence I needed going into final projects and was a great start to the year. A successful part of my final year was my foot drop 24-hour PDR live project. Myself and my group ended up in first place after developing a portable, breathable device that the user was able to attach it to a wide range of bike pedals to help foot drop rehabilitation. The design works with an embedded gyroscope and accelerometer to detect the motion of the user's leg. The user would wear an FES brace on the leg, which would stimulate the appropriate muscle group depending on where the leg is in the cycle phase. However, due to the short nature of the project, when we look back at our design as part of our field project, we noticed many flaws with the concept. We realised there was no need for any sort of pressure pad within the foot cage as the electronics work by gravity. Our design also looked very medical based and unappealing. Due to these issues, as a group we decided we wanted to develop this design further as our minor field project, in which we had 5 weeks to improve, adjust and redevelop the design. On behalf of my group, I organised a meeting of Dominic Egbeer from PDR. Dominic was the one who selected our design as winners of the competition, and we knew by meeting with him again it would give us the opportunity to ask if he had any advice on how we could improve or develop the design further based on his knowledge of foot drop. Dominic was very impressed with what we had achieved in such a short period of time. We explained our ideas and where we wanted to take the project. He told us that he had a sister-in-law, Laura, who has a foot drop condition, and kindly arranged a meeting with her to discuss the concept further. To prepare for this meeting with Laura, we re-entered the ideation stage. Instead of starting with a new design, we ideated ways on how we could improve our initial concept through means such as creative sessions and brainstorming. We figured out ways of improving the concept by selecting the good and bad aspects of the design. We then took the ideas we had and presented them to Laura to help identify the best possible solution for our design. During this interview we found out that with her condition it removes the possibility for her to know where her foot is while she's cycling. This causes problems such as her foot slipping off due to the lack of downward pressure. Another key thing she suggested was that a lot of people wouldn't want their foot permanently attached to the pedal for fear of falling off or needing to remove their foot quickly. Therefore, the decision to remove the strap but keep the foot cage was decided. To develop our design into a more functional, more appealing product, we chose to combine the pedal, the foot cage and the technology into one project. Here we can see the development process. Another key requirement for our design was that the user could be able to remove the pedal quick and efficiently. This was due to Laura suggesting that she would want to attach the pedal to multiple bikes. For this reason, we decided to incorporate a quick release mechanism into our final design. This allows the user to remove the pedal with a simple pull of the red latch. Our initial concept had a chunky, medical aesthetic, which in my opinion has now been replaced with the perfect balance between form, subtlety and function. With an elegant carbon fibre foot cage and a matte black nylon injection moulded pedal. The electronics are embedded at the front of the device, ensuring they are completely sealed in a watertight chamber. The foot cage can be removed with a simple twist of 2 aluminium screws located at the front of the design and replaced with a variety of different sizes depending on the user. As part of another 24-hour live project, DS Smith, a global packaging company, set us a brief to create a system or process to turn the last mile of delivery into the first mile of recycling. We started ideating with the principles of the circular economy in mind, considering solutions such as a points and rewards system, a self-sorting bin, and other various ideas that fitted in with the circular economy. After further development, we came up with a product and system to return the quality fibres back to DS Smith in the most cost-free, energy-saving way possible. The idea involves using an already existing DS Smith product, the fixed bin. These large cardboard containers will be used to collect all DS Smith packaging from around the campus. The system works by utilising delivery lorries as a means of waste disposal by taking away the fixed bins. This process not only utilises existing DS Smith infrastructure, it reduces costs and carbon footprint levels as extra lorries aren't needed to collect the waste. The housing of the units are made from injection moulded high density polyethylene. This material is weather resistant, has good strength to weight ratio and isn't too expensive. A lightweight lid on sprung hinges allows someone to open the lid easily and dispose of the cardboard. Our design comes in several sizes, so it can be used indoors and outdoors. Thank you for watching.